Now let's look at our last topic for chapter 3, which is 3.7. It is on electronegativity. And bond polarity. Okay. So, what do we mean when we talk about bond polarity? Okay. If we have two atoms of the same element, so let's say, just for example, we have two chlorines bonded together. All right. These are the same element. These electrons are spending equal time at both of these chlorine atoms. Right? But that's not always the case when we have two different elements. Let's look just, for example, at water. Right? Now, it turns out that oxygen tends to pull electrons to it a lot more than hydrogen. We'll talk about how we can know that here in a minute. But so let me just kind of magnify this and let's look just at one of these hydrogen-oxygen bonds. Right? So hydrogen or oxygen tends to pull electrons toward it more than hydrogen does. And so if we look at this bond, on average, these electrons are spending more time by this oxygen than they are by this hydrogen. This gives us something that we call a polar bond. All right, a polar bond. Now, if we look at this, okay, so if we look at what's going on in this bond, these electrons are over here by the oxygen more than they are by the hydrogen. Electrons are negative. So that gives us a little bit of a negative charge on this oxygen. Not a full negative charge, though. So to designate that, we use the lowercase Greek letter delta, right? Not capital delta, which means change, like we talked about in lab, but lowercase delta. Then we put a minus sign by it, right? So if this is minus, then the hydrogen has to be plus, delta plus. Okay. Now, when I've done this, I've created something called a dipole. Right? Here's what the dipole looks like for water. Here's how I illustrate a dipole. I draw an arrow and I point it toward the thing with the partial negative charge. And then I put a cross on that arrow by the thing with the partial positive charge. Now, how do I know what's negative and what's positive? That comes back to this property we call electronegativity. Which is the tendency for atoms to pull electrons toward them in bonds, right? Now, when we look at the periodic table, we look at this. Electronegativity is typically measured using something called the Pauling scale, developed by Linus Pauling. And he recognized that fluorine was the most electronegative element, ignoring the noble gases. He assigned it an arbitrary value of 4 for its electronegativity. Electronegativity decreases as we go to the left across the periodic table. It decreases as we go down the periodic table. Right? So, if I ask you what's more electronegative, oxygen or fluorine, you would of course say fluorine's more electronegative. I ask you what's more electronegative, germanium or sulfur, you would say sulfur. That's how that rule works. And that is electronegativity in a nutshell. We're not going to focus on memorizing specific numbers. There are some rules we can use by looking at differences in electronegativity, depending on how far apart to determine whether or not a bond is polar. But we're also going to just kind of ignore that. And I want you to just be aware of this relative trend. And that covers 3.7 and really all of chapter or the rest of chapter 3.